Right. Good afternoon, everybody, to another weekend webinar. Thank you so much for taking this time out of your day to join us for this webinar. I hope you guys enjoy it. Just in the chat box, you guys can hear me fine and you guys can see my screen. Okay, seems like everything is working. Cool. All right. So today's webinar, we will be going through some general SolidWorks features. And so let's jump right into it. As usual, just before we start, just some guidelines regarding the webinar. Just make sure your webinar, your cameras is off and that you are muted, just so that we don't have any interruptions. As you guys know by now, we will be recording this webinar, and also we will be sending this the link to download this webinar and the PDF of this webinar after this webinar. All right, so make sure to download that. Make sure also to chat to us while the webinar, the presentation is on. You can chat with us in the chat box. We will, me and my colleagues will be answering you there. And if you guys have any other questions, you're more than welcome to email us at support@mecat.co.za. And then make sure to connect with us on our social media pages, Facebook, Instagram, LinkedIn, and also our Daily Mecat Minute on YouTube. So check that out. Okay. Just another thing, so as some of you might already know, we are giving online training due to the COVID epidemic. So it's restricting us from actually giving on-site training or training at our offices. So make sure to, if you guys are interested in this, go and look at our training schedule, and you can book your spot there at training@mecat.co.za. So go and check that out. So today, our webinar will be presented by Dion Lagranchi, one of my colleagues. He is a qualified mechanical engineer and specializes in CAD and PDM. Our technical team is here to assist our customers with training, support, implementation, where we work side by side with companies to help them design better and also to streamline their workflow. Okay, so I hope you guys enjoy this webinar. I will be handing it over to Dion. So Dion, the webinar is all yours.
Thank you, Rudolph, for that warm welcome. We can jump straight in. You guys can let me know in the chat if you can't hear me maybe or can't see my screen.
From my side, I can, sorry, Dion, from my side, I can see and hear you, so it seems like everything's fine.
Thanks, Rudolph. Okay, so for today on the agenda, we're going to start off with the PDM environment. I'm going to show you a few, just the basics of PDM. I'll be working from a PDM environment, but I'm not going to go into too much detail on the PDM. There have been a couple of webinars on that already. Then we're going to go back into SolidWorks, and we are going to have a look at the structure system. Now, the structure system is quite a new feature in SolidWorks, introduced around 2018, 2019. And this is an extension to the normal weldments that we all know already inside SolidWorks. So we are going to take a look at the weldments as well. And then I'm going to do a very quick and simple part inside SolidWorks sheet metal. I'm going to show you how the sheet metal works. And I'm also going to show you how we can create flat patterns and DXFs very easily using SolidWorks sheet metal. Then once we have all our parts, we're going to put everything together inside an assembly. I'm going to show you how to use the SolidWorks toolbox if you have the toolbox with your SolidWorks Professional or Premium. And then at the end, I'm going to do just a very quick basic drawing. The drawings is probably worth a webinar on its own, so I'm not going to go into any detail on that. And then finally, I'm going to put those files back into my PDM vault, and I'm going to show you how we can create unique folders for standard components inside SolidWorks PDM. Right, so jumping straight in, I'm going to go to my SolidWorks PDM vault. Now, as you can see, SolidWorks PDM is just a normal folder inside Windows Explorer. You'll probably have to log in if you're not logged in yet. And what we have here is I've created a folder already with a few components inside it. Now, I really would like to advise you to make use of your SolidWorks PDM. If you are a SolidWorks customer with a SolidWorks Professional or Premium license, you already have access to SolidWorks PDM Standard. So it's going to make your life a lot easier using this, and you will be able to work much more securely with your files. Now, a lot of customers who use SolidWorks PDM prefer to have a sandbox folder like the one I've created here. This will be your folder in which you create new projects, new files. There might be some junk even inside this sandbox folder. And you will be creating your new files here until you're ready to move it to a new project. Now, I have created a new project files already. Once we are done creating our new files, we'll move these files into the project folder. But for now, let's just go back to our sandbox folder. Now, where we are heading with today's demo, I'm going to show you the completed assembly that I'm going to create inside this demo. So what we have here is a circular structure. Now, this is not really any specific assembly with a specific purpose, but it could probably be used to support something like a cylindrical water reservoir or anything like that. Then at the side here, we have a staircase. Now, this staircase, it contains a few sheet metal steps. And then these sheet metal steps, as you can see here from the side, it's held in place using fasteners that we will use from our toolbox library. Now, this may look like a very complicated thing to create, and it might take a lot of time, but I'll show you how simple it is using the structure system and weldments inside SolidWorks, as well as pattern features as well. So I'm going to return to my demo files here. Now, these demo files are essentially, it's basically empty files, but with the exception of a few settings that I've changed for the display, and also I've created a few sketches that I didn't really want to show you in this demo because it's really just normal 2D sketches. So we'll start out with our circular frame. We're going to open this inside SolidWorks. Now, using the structural system in SolidWorks, as I mentioned, this is a extension to the normal weldments we used to have in we still have in SolidWorks. It just makes it a lot simpler to create complex structures within a few seconds or within a few minutes using minimal geometry. As you can see here, we've got 4 planes, we've got a central axis, and a single sketch. Now, this single sketch, the only 2 geometry pieces we're really going to use here are these 2 sketch points at the bottom. So really minimal geometry, and we'll be able to create that entire structural system that I've shown you in the beginning, that circular structure. So let's launch our structure system. We can select the structure system tab and click structure system. Sorry, I just need to check this file out from PDM. Sorry, I forgot about this. Using our PDM add-in, I'm going to check out this file now. So now we've gained write access to the file. We launch the structure system, and we are going to start off with some primary members. Now, as we do the primary member, there's different options how you can create the location of those profiles. But before we do this, let's first define our primary members. So SolidWorks already comes with a library of standard components and standard weldment profiles or structural profiles. There are just 2 standards, the ANSI inch standard and the ISO standard. Now, we at MeCAD, we do have libraries for Max Steel, TubeCon, and RSA. So you can request those libraries from us as well. The structural member I'm going to use in this case is just going to be a normal I-beam. The size of the I-beam I'm going to select is the 120 millimeter I-beam. Right, so there's different options that we can now use to create or position these members in place. You could use sketches, planes, points, or you could even use the intersection of a plane with a face. In this case, we'll use the points. Now, for the end condition, there's also different end conditions that you can use. For now, I'm going to show you how we can use points, and we are going to create a chain of members along the points. So I can select the first point, second point, and then a third point. This creates a chain of lines. We could also use another end condition and select the up to plane end condition. Now I need to select a specific plane where I want to terminate these members. I'm going to select this top plane for now. Now, by default, the members will always be arranged so that it's perpendicular to the plane. But you could use any other sketch geometry as well to define a specific direction. So I can specify the direction by selecting this sketch line here. Right, so this is just one option of doing it. In this case, I'm just going to go right up perpendicular to the top plane. And for my two members, I'll select these points. Okay, so this defines our first two primary members. We can now click OK. Just give me a second, yeah. Right, so now we are ready to attach secondary members. Our secondary members are supported by the primary members. So we launch our secondary members, and once again, I'm going to specify another profile. So for the profile, again, I'll use a I-beam, and I'll use a slightly smaller one, the 100 millimeter I-beam. Now we are ready to define the position of these beams. Now there's also two options how you can define secondary members, either by using planes or by using specific points on another member, such as the endpoint, for example, of a primary member. Now, in this case, I'm going to show you both ways how to do it. We are going to use the planes option. For my primary members, I select these two upright members, the vertical members, and now I'm just going to use planes to define the position of four additional or four secondary members. So very quickly and easily, I just select those four planes. See how quick it is. Now, another thing we need to do here is, as you can see when I zoom in, is that the secondary members don't quite align with the top of the vertical members. So we can very easily just rearrange the positioning. So instead of using the centroid of the beam as the default is, we are going to use the top center of the beam to align with the planes. Right, so that gives us the correct orientation. We are not going to worry about the corners for now. Once we are done, we have assigned all our members, then we'll do the corner trimming on the individual profiles. So I'm just going to select OK for now. Now, one more thing I need to do is I want to add a diagonal member from this bottom left vertex over here to the top left endpoint of the beams. So again, I'll insert another secondary member. Simply click secondary member, define a new beam. In this case, I'm going to use the smallest one of the three. I'll select the placement options now, and instead of using planes this time around, I'll rather use specific points. In other words, the endpoints of my previous members. Now, the members involved in this positioning is going to be this bottom member over here and the very top member. Now, the distancing is also done very easily. I'm working with either a length ratio or a distance offset. So the offset I'm going to use is 0 millimeters from the endpoint of both those previous members. So you can flip the offset. For the second one, I'm just going to flip it to the opposite end of the member. All right, so that's more or less correct. Now, what we can see is that this member is oriented horizontally. Rotating a member is done very easily. Simply switch to your profile tab. Then I'm going to type in an angle of 90 degrees by which I'm going to flip this member. Right. Another important thing is that this member, this diagonal member, should be split in two places by the two horizontal members in the center. So very easily, I just select the option to split this member, and I select the members that should be involved in this split. It'll be these two members. Right, so now we are done defining our first structural system. We can now click OK and exit the structural system. Once we exit, SolidWorks automatically launches the corner management option. Now we have different types of corners, and SolidWorks immediately identifies this automatically for you. We have simple corners, in which case a member just joins along the length of a primary member. So you might see from the previews that it doesn't give a quite exact preview, but once you select those, the exact corner, you will see a better display of said corner. So here you can see this is fine. SolidWorks immediately identified the correct corner trimming. So we can switch to our two member. Now, this is where two members join end to end. There's different options here. I'm going to select a body trim so that one body trims another body to size. Now, you can change the order. Either the first body should be trimmed or the second. So to switch this, you just toggle the order of the trim. So I'm going to toggle it back to the initial trimming. That seems fine. Now for the complex trimming, this is where 3 or more beams intersect one another. Now here's 4 different corners. Let's just quickly go and have a look. Right, so the first corner is this one at the top. We can see that from the preview, it's not exactly the result we need. So what I'm going to do is I'm going to do a manual trim. So SolidWorks does allow you to do a user-defined trim as well when the trimming that it gives is not suitable for your case. So what I'll do then, I'll do a manual trim, and it's going to be a user-defined planar trim. So now I just select the plane which I need to trim this member to size. Right, so that preview is fine. On to the next corner. We can see that this preview is also 100% correct. The third corner is also correct. And then we should probably have the same issue with the fourth corner. Right, so exact same thing over here. We do a manual trim or a user-defined trim in which I will use that face to trim the member. Once done, we can click OK. Moving back to an isometric view, we can see that the members were trimmed to size exactly very quickly. Right, so we are now done with the first structure system. We want to use this structure system and pattern it around using 12 different instances along the central axis. For that, we select circular pattern. Now my circular pattern will be defined by a central axis over here. It's about a 4 meter radius. And for the features that we want to pattern, or actually for the bodies that we want to pattern, instead of selecting single bodies, we can just select now the structure system. Click on any of the members and it selects the entire structure system. So you can now set the amount of instance you want in that circular pattern. We said we want to use 12, so let's go with that. Now, before we are completely done with this structure system of ours, we need to apply a second structure system, which will add horizontal members between each one of these towers. So again, I just select structure system. Because I already have primary members, I will select secondary member. Again, we specify the profile first. And for this one, I'll use the 100 millimeter profile. Now, to the positioning of the members, in this case, I'll use my planes once again. And then I just select in pairs my opposite pairs of primary members. So 2 clicks will define a pair, and a third and a fourth click defines another pair, as you can see over here. Now I need to define the planes where these structural members should be aligned. So once again, 1, 2, 3, 4 planes. See how quick and easy that is. One thing to keep in mind now is that these members should also be aligned so that they are flush with the top of the other members. So we go to profile, and once again for the pierce point we select top center. Right, so SolidWorks already has a built-in menu that makes this selection very easy. But you could also select a specific point on the profile. So if I click here, I could select individual sketch points as well. But let's just select the top center point as mentioned. We can then click OK, and we can proceed to the trimming of the members. Exit the structure system. It launches the trimming or the corner management. Now again, I have multiple trimming types. There's a simple corner, a 2-member corner, and a complex corner. For all the simple corners, I'm now this time around going to select a body trim because the members does not meet, they meet at an angle. So I'll use body trim. The same with the 2-member corners, also just use a body trim. And then when we come to the complex corners, now we have a lot of complex corners here. I think, yeah, there's 10 complex corners. So I'm not going to do all of them. For this demo's purpose, I'm just going to do one or two of them very quickly for you. All right, so zooming in on that corner, we can see there's a slight problem out in the way that it is trimmed. So I'll just do a planar trim in this case. Once again, I select the user-defined option and I define the plane that will be used to trim the member. Let's do one more. It's this corner down here. We do a user-defined planar trim, and I simply select the face that should be used for the trimming. Right, so I'm only going to do those two. Click OK. Now we need to do another circular pattern of the second structure system. In other words, these horizontal members. So again, I just click circular pattern. For the direction, or to identify where the circular pattern should be placed, I select my central axis. Again, 12 instances around the full 360 degrees. And for the bodies that needs to be patterned, I will select my second structure system. Click OK. Right, so we are now done with the first part. Very quick and easy. We can save this and we can submit this back to our PDM Vault or check it in to update the latest version available to other members of our team. Then we can open the second part. Now this time around, I'm going to do the staircase on the side. Back to my sandbox folder. And once again, I check out the file to gain write access to the file. Now, yeah, nothing complicated. It's just a collection of 2D sketches. You will see that I have one main sketch. And then this main sketch I created a derived sketch on another second plane that is parallel to the first plane. Now, a derived sketch is based on my main sketch. So any changes that I do in the main sketch will immediately update in the derived sketch as well. Now, since this was a completely symmetrical part from left to right, I inserted a mirror plane. Now, this plane will be later on used to mirror different features. I'll show that to you soon. Then I have over here a platform plane, and I have my usual top plane. Other than that, just 2D sketches. Maybe to note, at the bottom here, I've also indicated in my main sketch the position of holes that I will create inside this weldment structure later on. Right, so let's start. This time around, I'm not going to use the structure system. I'm going to show you normal weldments. To define our weldment structure, I select structural member. Once again, from the same library, I select my weldment profiles. And this time around, I'm going to use rectangular tube, and I'm just going to use the largest one there is in the library, the 120 millimeter one. Then we define the location. Now notice that for weldments, unlike with the structure system, you need to have sketch lines to define the members. You can't use just planes or vertices and stuff like that. So we need to have those sketch lines that define the length and the position of our members. Also note that it does not need to be straight lines. It might be curved lines. It might be swept sketches, anything like that. Curves, anything. Now, we need to position now the members in the correct orientation. Notice that it is in a horizontal orientation. So I'm just going to flip it upright 90 degrees. I'm also going to relocate my profile, and you'll see why just now. In this case, I'll use the top center vertex. Click OK. Then I'm going to do an exact copy of that. I'll do 2 more structural members of the exact same type. And notice how SolidWorks remembers the members that we were using before. And I'll use the exact same sketch lines once again. Only this time around, okay, I'll need to rotate it 90 degrees once again. But this time around, we'll locate the profile at the bottom center vertex. So these 2 profiles might be welded together, one on top of the other. And click OK. Now we are ready to trim these members to size using our platform plane and our top plane. So I'm going to do a manual trim. I select trim and extend. For the bodies to be trimmed, I select those 4 bodies. 1, 2, 3, 4. The type of trim I'm going to do will be a planar trim. I'm physically going to use planes for this. And notice as soon as I select the trimming tools, SolidWorks will identify that my members are now split into individual pieces, and I can just toggle whether I want to keep or discard the remaining members. So I'm going to discard these 2 pieces at the bottom and these 2 at the top as well. Also interesting to notice how SolidWorks has extended this bottom member up to the plane. So before it was just it ended in a 90-degree planar cut. Now it was extended up to my plane. We can now click OK, and I'm going to do another set of members, again with the same structural member. This time around, I'm going to use individual groups. Now, the reason I'm using groups is that when you're making use of groups, all within the same feature, different groups of members can be used to trim other groups in the same feature. So for my first group, I will select these 3 lines. I need to reorient them. So I'll just rotate them 90 degrees in the upright position. And I'm going to locate my profile at the top center vertex, like that, to create the platform. Notice that the corners trim each other by default using a miter trim at 45 degrees. This might not be suitable, so I can then select each corner individually and change the trim type to end but 1 or end but 2. When it's not the one, it's just the other one. So there's no specific assignment to 1 or 2. Right, so that's fine for this member, and I need to do the same on the other side now. Click OK. Now I'm going to do a second group. The reason for this is that my profile is going to be oriented slightly different. So I select the option New Group, and I select these 2 lines. Now for these 2 lines, I'm going to locate my profile on, let me just see here, the top left vertex. Again, I select New Group to do a third member as well, or a third group of members. And I select this line at the bottom. This time around, this one is going to be located using the bottom right vertex. So quick and easy to align your profiles. And members within the same feature will trim one another. But because these first 2 diagonal members were created in a different feature, they won't trim the members in the other feature. So they will have to do a manual trim. But this is also done very quickly and easily. For the bodies to be trimmed, we simply select those 2 bodies. And for the face that will be responsible for trimming, we select this face over here. Again, make sure that we just discard the remaining pieces by just toggling those flags, simply clicking on it once, click OK. Next, we need to trim this member as well. Oh, okay, this one is fine. It's already trimmed. Then finally, the member at the bottom. So also a manual trim. Select the body to be trimmed. I'm going to do a planar trim using those 2 faces. And notice how SolidWorks is slightly intuitive. It recognizes that those 2 smaller pieces on the side will be discarded. So I can just click OK. Right. So I'm done with the first part of this structure. Before we're going to do the handrails, what I'm going to do next is I'm just going to create a platform first. So my platform, I'll just create a new sketch on this face over here. Just a normal 2D sketch where I use a rectangle. And notice how I don't use dimensions to specify the size of this rectangle. Instead, I use the existing geometry to identify the position of my rectangle. The reason for that is changing then the structure itself will update the size of my platform along with it automatically. Then I'm just going to do a normal extrude. This is just going to be an 8mm thick platform. I do an extruded boss, 8mm in thickness. Click OK. Now I'm ready to do my handrails. Again, for this, I will use the normal weldments. Select structural member. And this time around, I will use pipe. And I'll just use the largest one we have here. And again, I'll do 2 separate groups. So for the first group, I'll just do a chain of lines. 1, 2, 3, 4. Okay. So zooming in, we can see that the default corner trim type will be a miter trim. In this instance, the miter trim is fine. I'm now going to go ahead and I'll do the rest of the vertical members as a separate group. Now I select all my vertical members. Now keep in mind that the order in which you select these groups is important because any group will be trimmed by a group before that in the list. So my group 2 will be trimmed by group 1 and not the other way around. So let's have a look at how these members are trimmed. All these vertical members are trimmed to group 1. Now, at the top here, I might prefer maybe a different type of trim. Let's say over here, I want these 3 members to all trim into one another equally. What I can do then is I can change the trim order for the 2 groups. So if I take the second group and I change its trim order to 1, then both groups will have an equal influence on the corner. And that way, all three components or all 3 members will blend equally into one. So again, select the second group, decrease the trim order so that the 2 orders are equal. Click OK. And this is what the result will look like. So very easy to manage your corners. Keep in mind that we now just need to trim the bottom pieces of those vertical members. And for that, I'll use 2 separate trim features. For the bodies to be trimmed, I select those 4 members. For the trim type, it's going to be a planar trim just using the face of my platform. And once again, notice how SolidWorks intuitively knows which parts should be discarded and what should be kept. So I can just click OK. And then finally, I'm going to do a trim on these 6 vertical members down the side. So another trim feature. And what I want to show you here is that you can do a planar trim, but you can also do a body trim. So if I select the bodies option, I can then select these 2 bodies along the sides. Once again, SolidWorks intuitively knows which parts to discard and what to keep. So I can click OK now. Right, so we are done with the main structure. What we need to do next is we need to create holes where the stairs that or the steps that we insert will be bolted to. Now, this might not be the most optimal way to create these steps, but just for demonstration, I'm going to show you now how we can use the hole wizard feature. Now, a hole wizard feature is quite a powerful feature. Unlike just creating a cut using a circle, the hole wizard feature actually contains a library of preset types of holes. So you can have countersunk holes or just normal holes like the one I'm going to do here. So I select the hole option, and there's also different hole standards. There's BSI, then ISO. I'm going to use ANSI metric in this case. For the type of hole, it could just be a normal drill size, or I could use, like in this case, I want to use screw clearances. So the hole is not defined by specific dimensions. Instead, the hole is defined by the fastener that will fit into the hole. In this case, I'm going to use an M10 fastener, but I want a loose fit. Now, although I'm using a M10 fastener, if I select loose fit, it will actually create a hole with a 12 millimeter diameter. Now, before we continue with the rest of the steps, let's switch to the positions tab. Using the positions tab, I'm going to identify the face where I want the hole to be created. I'm going to switch normal to this face. And I'm just going to use my predefined sketch and identify 2 holes to be drilled into the side of that member, like that. Switching back to the type settings, we can now define the end condition for these holes. Now, instead of using through all or through all in both directions, I'm just going to use the up to next setting. If I use the up to next setting, instead of cutting through both members, through both faces of both members, it'll just intersect with the next face that it meets in its path and cut through that face. I can now click OK. So my hole has been defined. Obviously, we need to create much more holes than just these 2 holes. We need to create holes along the length of the profiles, as well as on the profiles on the other side. Now, for both of those instances, I'll use patterns. So the first pattern I'm going to do is going to be a linear pattern of this hole feature. I select the option linear pattern, and to define the direction of my holes, I'll use any one of these lines. Since they are parallel, I can select literally any line in that direction. So for the features that we need to pattern, I'm going to select from my flyout feature manager tree the very last feature that was created. In other words, this M10 hole. Now, I want to define my pattern by using spacing and the amount of instances. In this specific case, I'm going to use 311 millimeters. The reason for that is since this is a 40-degree angle, this will result in more or less a 200 millimeter vertical increase in height. So just looking at it from the side then, I can now increase my amount of instances, and in this case, around 17 steps should do. And you can see the preview updates live, so I can just click OK now. This was the first pattern type. Now, for the second pattern type, I'm going to use a special pattern type called the mirror. And since this is a symmetrical part from left to right, I will select my mirror plane to define the mirror. And for the features to mirror, I'll just select the previous feature, which was the linear pattern of holes. So it flips it across to the other side, and I can just click OK. Right, so we are now done with this part as well. I'll save the part and I will check it into my PDM vault so that it updates in the vault and other users can see my changes. Let's continue now by creating those steps that we want to create from sheet metal. Once again, I browse to my vault and I check out the sheet metal step file. Just note that this is not actually a step file, it's a SolidWorks part, but it's just the step. So what I've created here is two sketches. The first sketch defines the width and the layout of the step. The second sketch is where I should place the holes. So once again, just normal 2D sketches I've created. Now we switch to our sheet metal tab. In the sheet metal tab, I select base flange to define the first feature of a sheet metal part. And I will select my base sketch for this. We can define a thickness. So our thickness we want to use is going to be 5 millimeters. And now the next thing I'm going to do is I'm going to insert edge flanges on both the left and the right at the same time. I select my edge flange feature and I simply click the edge that I want to use. Now I will flip the direction towards the bottom, and because I'm creating both flanges in the same feature, I can be sure that both flanges will be exactly identical and should update as such. Now for this, I'll use a blind depth of 40 millimeters. And you can also define how that 40 millimeter depth is measured. Is it measured from the inside of the bend or from the outside of the bend? In this case, I want it to be measured from the outside of the bend. In other words, from the top of the component. Now, it's important to keep in mind that this first sketch, that rectangle you saw in the beginning, defined the total width. If we add these edge flanges now, we are going to change the width and our part is not going to fit. So the position of the edge flanges can also be changed. Instead of adding it towards the outside, I can select the option material inside. That will maintain the width and it will still stay within my boundaries. I can now click OK. And now next I need to add 2 more flanges. This will ensure structural integrity so that these steps don't bend under weight. One edge flange at the top. Again, I'll use a blind depth of 50 millimeters. But now in this case, I want that distance to be measured from the inside of the bend. So also from the top of the component. Now to create a corner, in this case, if I add the bend like this, material inside, it's going to tear my sheet metal over here. But in this case, it's fine. I have some space left, so I can add it on the outside of the profile. Click OK. And I'm then going to create the last edge flange. Select my sketch or my edge. Now, in this case, I would like to have the depth of this edge flange to be the exact same as the edge flanges on the side. An easy way to maintain this, instead of selecting a blind depth, I can select the option up to vertex. And then I just select the vertex over here. Click OK. Last thing I need to do is I just need to insert the holes. Now, I'm not going to use the hole wizard feature again because this won't be machined holes. These holes will actually be laser cut into the component already. So I can just use a normal extruded cut for this. I'll redo sketch. Okay, and I have multiple contours. So I'll just select the other contour as well. And for the end condition, I'll use through all in both directions. That should give me the desired result. We're actually done now with this step. So just something I want to show you quickly is, as we created new features in our sheet metal component, we actually created the flat pattern already. So generating a flat pattern is as easy as simply selecting the option to flatten. Right, so here I've got my flat pattern. I can easily toggle between the flattened and the folded state. And if I want to generate or export a DXF for this component, I can simply right-click my flat pattern and select Export to DXF. Now this DXF, I can put anywhere in my vault. I'm just going to put mine on the desktop for now. And I can hit the Save button. Upon clicking the Saving button, I now have export. I can now go ahead and I can place similar fasteners. Notice how quickly it snaps into position on that hole. As soon as I get close to it, it snaps into position. I just left to click to place. Now it's still free to rotate. If you are really the perfectionist, you can make those faces parallel if you want. I'm not going to do it now. So I'm simply going to insert my step now using insert components again. We insert our metal step. The first thing I'm going to do is I'm going to make those two faces parallel to one another. Then that circular or that hole in the background, and I can select this hole as well. I'm going to make these two concentric. Once again, notice the intuitivity inside SolidWorks. It already highlights the concentric mate type. Okay, so now I still need to fix the position over here. The back face of the step needs to be mated coincident to the front face of the nut. Now, sometimes it can be quite complicated. If I would like to mate two components together and I need to make a selection on the back face, usually you would rotate the component to select the back face. However, SolidWorks provides the opportunity, if I select the face blocking my view, I can select the option Select Other. When I select Other, I can now select the face in the background. And after my selection, the faces return to their previous visibility. I select the face in the background and I simply select Coincident. Right. So the next thing I want to do now is I still need to add two bolts as well. From my toolbox library, I can go to bolts and screws, select hex nuts, and I'll select just the second one. Sorry, not nuts. Sorry, bolts. I'm in the wrong folder. Bolts and screws. And I can just use this one. Drag into position. And drop. The M10 fastener is fine. Notice how it already selects M10 because I used an M10 nut. I can now click OK, and I can insert my second fastener. Right. Now, obviously, there's a lot more fasteners and steps that we need to insert, but this we will also do using component patterns. The first thing I want to do is I would like to mirror these 4 fasteners to the left-hand side. I will do this using a component pattern, specifically mirror component type. When I select mirror components, it prompts me to select a mirror plane. Now, my assembly does not contain a mirror plane, but I do have that mirror plane inside the staircase component. So I can just expand the staircase component, access its features, and select mirror plane. For the components I would like to mirror, also a quick selection, I can just do it either from the graphics area or from the flyout feature manager tree. I select the 4 components. Select OK. All right, so we can verify that it was created on the opposite hand. Right. Now, the second pattern type I would like to do is a pattern-driven component pattern, because these stairs and the fasteners, all of it needs to be patterned along the pre-existing pattern in which I created these holes. So that's also done very simply. I go to my linear component pattern, the drop-down underneath it, and I select a different type of pattern, which is the pattern-driven component pattern. Now, for the components I would like to pattern, you can either select from the graphics area, or I can select my fasteners from the Flight Feature Manager tree, as well as the mirrored fastness on this side. So 9 components in total. Now it prompts me to select the driving feature or component. This will be the previously defined pattern, which was defined inside the staircase part. So I'll just expand that and select the linear pattern. Notice how the preview shows me what the result will look like, and I can just click OK. So just like that, I created quickly and easily 17 copies of the step along with its 4 components, attaching it to the structural members. So we are now done with creating the assembly. I can save, and I will check this file into my vault. Right, so we're quickly going to do a very simple drawing. Go to File, Make Assembly from Drawing. I will use my A3 template. And in this case, I'll just insert an isometric view. We can maybe hide the sketches that were part of the part and assembly files. So we hide the sketches. And maybe we can change the scale from a 1 to 100 scale to a custom scale of something like 1 to 50. Right. So that's the only part of the drawing I'm going to do, very quick and easy. I'm going to save this drawing now as a new file to my vault. Also inside my sandbox folder, demo files. And we can just hit the save button. Add the file to the vault, that's fine. Usually would fill out the data card, inserting more property values, but in this case, I'm not going to do this. We are now done on the SolidWorks side. You can just close all these files. Now we're heading over to our PDM vault. Just remember to check in our drawing as well. Now, the reason why many people would have a sandbox folder is you are going to create some junk maybe inside the sandbox folder. In our specific vault, we use a numerical numbering convention or naming convention for our files. So all our CAD files will be called DOC dash and then given or assigned an 8-digit serial number just running sequentially. So in this case, what I'll do now is I'm ready to move these files over to my project folder to project number 3. So what I do is I select the top level file, which is the drawing containing all the file and referencing all the other files. So I go to tools and I select copy tree. Now this is much like the pack and go feature that you use inside SolidWorks. It's just much more powerful inside SolidWorks PDM, and it utilizes PDM features. So I can now go ahead and I can select the location. I'm going to browse to my projects, project 3, CAD files. I select this folder. Now notice when I do a pack and go, how my toolbox files are excluded from the copy tree. I don't want to create unnecessary junk and duplicates of the exact same files every time inside my PDM vault. So by default, when you manage your PDM, your toolbox from PDM, those files will be excluded from copy tree. Right. So now the copied files, we would like to rename these files with a serial number. I select the option to rename with serial number. Now, in our specific case, our vault uses the exact same serial number for parts, assemblies, and drawings. So we can just click OK. And as soon as you've clicked that, notice how our file names are updated. Files with an updated name will be highlighted. And you can see it uses a sequential serial number, 49, 50, 51, 52. I turned on the setting to name drawings after their model, so just the file extension for drawings and assemblies will differ in this case. There's the option to check in the files immediately on copy, and I can also create a comment such as first submission to Vault. And I can select now the copy option. Right, so now it's creating all those files. It's moving it over, or actually copying it over to us from our sandbox folder to the project folder. Now, At this stage, we could clear our sandbox folder and delete all the junk files that were created after moving it to the projects folder. So just to show you the result now, inside CAD files there, all my files are now renamed using the correct naming scheme. Notice also how my drawing and the contained assembly shares the same file name and number, therefore. Now, in a case such as this, where all these files were created as brand new files, it's fine. We're not going to create any duplicates. But for example, this stair file, this will be a standard component. It will also be referenced in other new assemblies that we create. Now, when we move those new assemblies then from our sandbox folder into a project folder, we are therefore going to create duplicates of the staircase file. Now, the nice thing with SolidWorks PDM is the first time that a file is shared between multiple projects, you can simply take that file. I'm going to cut this file and I'm going to put it inside my standard components folder. I'll also put my toolbox inside the standard components folder and I can just click paste. References won't be broken because PDM is intelligent in this way that next time you open the assembly, it remembers that the file was either just renamed or moved. So what we need to do now is we need to make this standard components folder a special folder so that all the files contained within that folder will not be selected for copy tree. Now for this, you need to go to your admin tool of your PDM Vault. If I now go to administration, go into my Vault settings, I will go to my user groups. Now this setting needs to be updated for each and every user inside your Vault and for all groups as well. Now I have an all users group which contains all of my users, so I'm just going to do it in one place. You can go to the copy tree node and then you can select your standard components folder. I will turn on the setting to exclude all files and subfolders in that folder to be excluded from copy tree. I will now click OK and the setting is saved. So let's assume that we were creating a new project now inside our sandbox folder. I'm just going to go to the exact same project. If we do another copy tree now of this drawing, I go to Tools and I select Copy Tree. I will rename the files using a serial number. But notice now that this time around, that file 1951, which is the step file, that file is now a standard component and it will be excluded from copy tree. So I will no longer be creating duplicate data inside my Vault. This way you can now select a new folder to insert those files into, and both projects will now reference the exact same file. So I can now just select copy. Right, so that is basically that for the demo or for the webinar. All I wanted to show you for today. I'm now going to hand over to Rudolf and he's going to ask some poll questions quickly before you leave. Thank you very much for your time.